Hello everyone and welcome to this video of the course Robotics. In this video we are going to talk about getting started with Programmable System and working with microcontrollers. The topics that we'll be discussing in this video includes Programmable Systems, Introduction to Microcontrollers, the difference between microcontrollers and microprocessors, and we'll be getting started with one of the Programmable System board, development board, that is Arduino's. We'll be learning some basic fundamentals of Arduino programming, and we'll be also discussing about ADC and its application and its role in Arduino. So let's get started with that. The very first thing that we talk about is a programmable system. Now the question is, what exactly is a programmable system? So the answer would be, a programmable system is anything that can carry out a sequence of operations via instructions from the user. Anything that can store some instructions and it can execute some instructions that we have stored into it. An example of this is a VCR, which can be set to record play via remote control or a touchpad. An alarm clock is a programmable system, as is a microwave oven, an iPod, a TV, or a laptop. The common thing in all these devices is they carry some infrastructure to store a particular program or set of instructions and follow those instructions. Whereas a non-programmable system is the one with a fixed function, that is a thermostat or a standard light switch, which do not have any set of instructions. It only follows the logic through which it is connected in hardware mode. Talking about what sort of things that we need for designing a programmable system. So if we talk about our laptop or a computer itself, the necessary things that we have in a computer is RAM for storing the temporary data, processor for processing the instructions, the flash memory for storing the permanent data, that's our hard disk that is storing the operating system in it, and we have some input-output ports that is allowing us to connect input-output devices like keyboard, mouse, and monitor with our central processing unit, that is CPU. So in a programmable system, the basic necessary things that we need for designing a programmable system is processor, RAM, flash memory, input-output ports, and power supply as well. Now, for designing a small-scale programmable system, we do not need these features as much as we have in the computers, like RAM in GBs, flash memory in 500 GB or 1 TB, process speed in terms of gigahertz. For designing a small-scale programmable system, we don't need this much of quantities with this sort of resources. We need these resources, but we don't need in this much of quantity. So alternative to that is using an IC called microcontroller, which is an IC which combines all these things in a small scale manner. Processor with low processing speed in terms of megahertz, RAM with the size in KBs, flash memory with the size in KBs. Combining all these things on a single chip is called microcontroller, which can be used as a standalone programmable system. So in our course, for designing a programmable system, we are going to use a microcontroller. Talking about what exactly is a microcontroller. A microcontroller can be defined as a computer on a chip. It means the complete computer, including the flash memory, including the RAM, including the processor, the input-output ports, and other peripheral devices, other peripheral interfaces, everything on a same chip can be called as a microcontroller. So it has the input-output ports, a processor embedded on a single chip, and memory, RAM and flash both. A microcontroller can be called as a complete, self-sufficient, intelligent system, usually requiring no external component. There are a variety of microcontrollers in the market, manufactured by different companies, and based on the amount of resources they are attaining, people use and developers use any of the suitable microcontroller. Talking about the difference between microprocessor and controller-based systems. So microprocessor is the central processing unit on a single integrated circuit, for example AMD Athlon or Intel Pentium, whereas a microcontroller is an integrated CPU along with memory, a small amount of RAM and a program memory or both, and peripheral cable capable of input and output. Everything on a small chip is in microcontroller. Example, Atmega AVR series microcontrollers or PIC microcontrollers. Talking about the difference between a microcontroller and a microprocessor based systems. Some microprocessor based systems are relatively large because everything has to be attached separately: separate RAM, separate microprocessor, separate flash memory, and separate input output ports. Whereas microcontroller based system is very compact, small in size, because everything is embedded on a single chip. And because everything is embedded on a single chip, microcontroller based systems consume relatively less power compared to microprocessor based systems, wherein each and every device is connected separately and has to be fed a separate power. Microcontroller based devices or systems are relatively cheaper in cost compared to microprocessor based devices and systems. So in case if you wish to design a small scale programmable systems, microcontrollers are more preferred over microprocessor based systems. There are various types of families of microcontrollers like AVR, that is Advanced Virtual RISC, which is based on RISC architecture, reduced instruction set computing. A051, one of the earliest microcontroller, the ancestors of microcontroller family. PIC microcontroller by Microchip. ARM microcontrollers, ARM family microcontrollers, and many more other microcontrollers are there into the market. The one that we are interested in is AVR series of microcontrollers by Atmega Corporation. AVR is a modified Harvard architecture 8-bit RISC single-chip microcontroller developed by Atmega in 1996. So AVR series microcontrollers are 8-bit microcontrollers. They are based on RISC architecture, that is reduced instruction set computing. AVR was one of the first microcontroller families to use on-chip flash memory for program storage. The basic families in AVR includes tiny AVRs, that is Atmega11. An example of it is Atmega11. Mega AVRs, an example of it is Atmega 8, Atmega 16, Atmega 32, Atmega 328, Atmega 168. And we're going to use the Arduino from the family Mega AVRs, that is Atmega 328. And Xmega family, that is example of it is at Xmega 64. So there are various families in AVR, and most of them are based on the RISC architecture with 8-bit instruction size. Talking about the device architecture of a microcontroller, the very core thing in a microcontroller is ALU, that is Arithmetic Logic Unit. The Arithmetic Logic Unit fetches the data, decodes the data, and executes the instruction. There are registers in the microcontroller, usually 32 into 8-bit registers. The CPU or the processing unit in the microcontroller does all the calculations on these registers. The another unit in the microcontroller is the program memory. Program memory is used for storage of instructions that form the program. A non-volatile flash memory is used to store the program. The size of program memory is occasionally indicated in the naming of the device itself, that is Atmega 64X. The line has 64 KB of flash memory. In our case, we are using Atmega 328, so the microcontroller has 32 KB of flash memory. Another component is static RAM, that is static random access memory, that is used for storage of data variables, temporary variables, stack, etc. Another important unit of a microcontroller is EEPROM, that is electronically erasable programmable read-only memory. It is used for semi-permanent data storage like flash memory. EEPROM can also maintain its contents while electrical power is removed. So this is the basic idea of device architecture, which consists of ALU, arithmetic logic units, the registers, the program memory, the static RAM, and the EEPROM. Next, now let's start with Arduinos. Arduinos are the development board which uses microcontroller families of AVR, and based on that it customizes the use of microcontrollers in a simple manner so that it is very simple to use for designing small scale programmable systems. So Arduinos are the series of boards with microcontrollers on board, mostly AVIA series microcontrollers on board, and can be used as a ready-to-use programmable systems. So Arduinos are not a microcontroller, Arduinos are not ICs, they are a development circuit board which uses AVIA series of microcontrollers for programming. And Arduinos are open source boards, so it's designed very easy to use. So let's look after some of the properties of Arduino boards. Arduinos are open source electronics prototyping platform. Being open source, it is widely used throughout the world. The circuit diagram and the firmware of Arduino is available openly on the website arduino.cc. So you can design your own board or you can buy the board available in the market. Being open source, it is widespread throughout the world and you can find Arduino boards throughout the market anywhere in the world. It's an easy to use hardware because the pins of the microcontroller are customized in an easy to use way, and the software is the easy to use. In fact, the Arduino programming language is considered as world's one of the easiest programming language. Arduino hardwares and Arduino boards are cheaper and easily available. And the software of Arduino is an open source software, so if you're designing and developing any new hardware, you can also develop Arduino library for it and make it compatible with Arduino and use Arduino programming interface to program your own hardware. Arduino boards are generally widespread and many projects are openly available on Arduinos. And extra hardware shields are available. Means, in case you want to interface some other devices like Ethernet, memory card, GPS, GSM, now you don't need to worry about the interfacing circuit for interfacing that particular module with Arduino, because the shield for interfacing those sort of devices with Arduino are ready-made available in the market. So development is very easy with Arduino. One of the best part is it is USB programmable. You don't need to use any self-programmer programming Arduinos. It's very easily programmable using the USB type 2 cable. So these are basic ideas of Arduino, and being open source, more amount of community support is available for Arduinos compared to other boards on internet. So for any kind of development you're working on, it's easy to get support, it's easy to get ideas for doing anything with Arduinos. So let's start with Arduino's part. We have a couple of boards of Arduino. On the top left you can see the board that we are going to use and which is widely used throughout the world is Arduino Uno. The next to top left is Arduino mini board, which is a mini version of this and has similar features to Arduino Uno. The top right board is the backup version of it, that is Arduino Mega using Atmega 2560 microcontroller. Has more resources in terms of more number of digital input output pins and more number of UARTs and more amount of memory as well. The bottom left circuit is an shield for Arduino Uno, Ethernet shield for Arduino Uno. In case you wish to use Ethernet with Arduino Uno, you can use this Ethernet shield along with Arduino Uno to combine the two boards and use them along with Ethernet and connect them to internet. The right to Arduino Mega board, the circular round shape board, is Arduino LilyPad, which is a flexible circuit, can be used for designing or programming wearable devices. Let's talk about the board that we are going to use, that is Arduino Uno. Arduino Uno board has the customized pins of Atmega 328, and after customizations we have total 14 digital input output pins, that is pin number 0 pin number 13. So from pin number 0 pin number 13 on Arduino Uno board can be used as digital input and output devices interfacing pins. So any digital input and output pins you have, any digital input and output devices you have, you can easily interface them on pin number 0 pin number 13 on Arduino Uno board. As the microcontroller can process the digital data easily, it is easy to interface digital devices with microcontroller. But in case of analog input devices like environmental sensors, they generally provide analog signals. Now for a microcontroller to process those analog signals, it needs to have an ADC with it. Luckily we have 6 ADC channels on board with Arduino from A0 to A5. So pin number A0 to A5, 6 pins can be used for interfacing analog input devices, as those pins do have onboard inbuilt ADC with the microcontroller Atmega 328. We also have 6 analog output pins, that is on pin number 3, 5, 6, 19, 11. Using PWM, digital pulses can be manipulated to behave like an analog one, which we'll be looking in coming videos. So the overview of Arduino input output devices: it has 14 digital input output pins, 6 analog input pins, and 6 analog output pins. So this is a basic idea of Arduino you need to have as of now. Talking about other features of Arduino, you can see over here we have 0 to 13, the 14 digital input output pins, A0 to A5, the 6 analog input pins, and 3, 5, 6, 19, 11, the 6 analog output pins. Other than that, we also have up to pin number 13 we have ground pin and analog reference pin for ADCs. You can also see the reset button on Arduino, which can be used to reset the Arduino anytime. There is type 2 USB port on Arduino, which can be used to connect Arduino to PC using USB type 2 cable. Arduino can also be powered using external power supply with the DC power jack of Arduinos. On pin number 0 and pin number 1, Arduino has UART port, that is for doing serial communication, which are also multiplexed with the USB of Arduino. So the program is uploaded using the same UART, RX and TX on pin number 0 and 1. So RX is receiver, TX is transmitter, used for UART, universal asynchronous receiver transmission communication using serial communication UART mode on pin number 0 and pin number 1. We also have in-circuit serial programmer, that is ISP programmer, ICSP programmer on Arduino, which can be used to connect SPI interfaces or SPI USB ASP programmers to program Arduinos. Just above to the analog input pins we have power bus pin, wherein we have analog, wherein we have voltage input, ground pins, 5 volt power pin, 3.3 volt power pin, and reset pin, which can be used to connect input and output devices to power them up. This is the basic idea of Arduino Uno board, and as soon as we move on with doing some practicals, we'll be further exploring other benefits. We'll be further exploring other properties, other features of this board as well. Talking about the features of microcontroller Atmega 328, it is an 8-bit microcontroller with the clock speed up to 16 MHz and flash memory 32 KB and RAM memory, that is static RAM, up to 2 KB. With 28 input-output pins, it is the complete package to be used for any programmable system. Talking about the input-output pins of Atmega 328. Atmega 328 is a 28-pin IC with ports are port B starting from PB0 to PB7, 8 pins on port B. Port C starting from PC0 to PC6, 7 pins along with ADC. Port C also has ADC from PC0 to PC6, and out of that PC0 to PC5 are matched with Arduino Uno, and PC6 is given to reset pin. Port D, which is ranging from PD0 to PD7, eight pins on port D, and PD0 and PD1, that is RX and TX, is matched to pin number 0 and pin number 1 of Arduino Uno. Other than that, we have VCC and ground on Atmega 328 and A reference and AVCC on Atmega 328 for operation of ADCs. Now let's talk about some basic idea of programming and C programming language. Talking about C programming language, we first power on the device, reset the device, and upload a sketch on Arduino. After uploading the sketch on Arduino, we execute the existing sketch and the LED starts blinking after 5 seconds. So this is the simple idea of blinking LED using Arduino. So programming in Arduino, we first write the program, compile the program to check for errors, and compilation also converts the program into the bit format, that is 0101 bit format. After that, we reset the board and upload the program to the board. So there's a simple process for writing a program and uploading a program to the board. That's writing a program, compiling the sketch, resetting the board, and uploading the program to the board after selecting the port number of the Arduino connected with your PC. An Arduino sketch has general three parts. That is, first we declare the global variables, then we have void setup function, and then we have void loop function. So all the global variables we declare at the top, and we initialize or do some settings, and the command that we wish to run only once we write into void setup part. So whatever command we are going to write in the void setup part, that is going to run only once at the beginning. And the main program that we wish to run repeatedly, that we write into void loop afterwards setup part. So this is a basic part of Arduino programming. You have global variables, void setup function, and void loop function. To remember that variables are declared at the earliest, then the settings are the program that you wish to run only once are put into void setup, and the main program that you wish to run repeatedly is put into void loop. Talking about some syntaxes of Arduino, so one of the syntax is pin mode. We know that on Arduino, pin number 0 to pin number 13 can be used as digital input and output mode. It means any digital input and output device you wish to connect with Arduino, you can connect on pin number 0 to pin number 13. To configure whether your device is input device or output device so that Arduino can understand whether it has to source the current or sink the current, you have to use the syntax pin mode. So pin mode generally configures the specified pin to behave either as input or output. You can see the description of digital pins for details on the functionality of the pins. As of Arduino 1.0.1, that is Arduino Uno R3 as well, it is possible to enable the internal pull-up registers with the mode input_pull-up. Additionally, the input mode explicitly disables the internal pull-ups. So you can define the pin mode as input, output, or input pull-up. The syntax used is pin mode, where M is capital, the name of pin, the mode of it. The parameters that you pass is pin and mode. Pin is the number of pin which you wish to set as input or output, and the mode could be input, output, or input_pull-up. So this is the basic idea of pin mode. And anywhere if you want to use for any device you wish to use the pin number 0, pin number 13, you have to declare the pin mode to make it work properly. The next syntax is digital read. We know that with our programmable system we can attach two types of devices. One of them is input device, another is output device. Every input and output devices can give or take two types of signals, that is analog signal or digital signal. In case we are working with digital input devices, we can connect the digital input devices from pin number 0 to pin number 13. And for getting data from digital input devices, the syntax that we can use is digital read. So digital read reads the value from specified digital pin, either high or low. The syntax is digital read the pin. The pin is the number of digital pin that you wish to read. Next syntax is digital write. In case we wish to work with digital output devices, the syntax we'll be using is digital write. Digital write does write high or low value to the digital pin. If the pin has been configured as an output with the pin mode, its voltage will be set to the corresponding value 5 volt if we write high and 0 volt if we write low. If the pin is configured as an input, the digital write will enable high or disable low the internal pull-up on the input pin. It is recommended to set the pin mode to input pull-up to enable the internal pull-up register. The syntax is digital write pin, value, where pin is the pin number and value can be high or low. The next syntax is analog read. In case you are working with some devices which provide analog signals like sensors or potentiometer, in that case, for reading data from those connected with the pins of ADC, that is from A0 to A5, you can use the syntax analog read. Analog read generally reads the value from specified analog pin. The Arduino board contains a 6-channel, 8-channel mini, nano, and 16-channel on mega 10-bit analog to digital converter. This means that it will be able to map the input voltages between 0 to 5 volt into the integer values between 0 to 1023. This yields a resolution between the readings of 5 volt by 1024 units, or you can say 0.00549 volt or 4.9 millivolt per unit. The syntax for analog read is analog read. In bracket, we provide the pin where the sensor is connected or the device is connected up. The pin parameter is the number of analog input pin to read from 0 to 5 volt on most boards, or 0 to 7 on the mini and nano, or 0 to 15 on mega. Next syntax is analog write. In case we wish to control the voltage, output voltage on any component or on any pin of Arduino, we can use the analog write syntax. The analog write syntax writes an analog value or PWM wave to a pin ranging from 0 to 55 in the case of an 8-bit microcontroller. It can be used to light an LED at a varying brightness or drive a motor at varying speed. After a call to analog write, the pin will generate a steady square wave of specified duty cycle until the next call to analog write. The frequency of PWM signal on the most pins is approximately 490 Hz. On the Uno and similar boards, the 5 and 6 are the frequency of approximately 980 Hz. The syntax that we use for analog write is analog write pin comma value, where pin is the number of pin we write to. In case of Uno, it can be pin number 3, 5, 6, 9, 10, 11, and the value is the duty cycle between 0 to 255, where 0 is always off and 255 is always on. Now we'll talk about ADCs. In electronics, an electrodigital converter or ADC or A by D or AD or A to D converter is a system that converts an analog signal such as a sound picked by a microphone or a light entering a digital camera into a digital signal. An ADC may also provide an isolated measurement such as an electronic device that converts an input analog voltage or current to a digital number proportional to the magnitude of the voltage or the current. Let us say that ADC is of 10-bit precision, then it will convert 0 to 5 volt values to 0 to 1023 digital bits. For example, let's say that we have a switch with connecting to ground and 5 volt, and it is connected to one of the pin of pin C where ADC is connected. Let's say if the switch is off and the input is pulled up, so we'll be getting a value 1, and if the switch is pressed, we'll be getting value 0. By using a multiplexer on a particular pin, which has a lot of pins like 0 to 7, we can multiplex the value from 0 to 5 volt using a multiplexer, and that value can then be fed to an ADC. And by varying the level of multiplexer, the ADC can convert the multiple varying values to a particular value between 0 to 1023. In case of Arduino, for generating an analog input or for getting the analog input, we use the syntax analog read, and the resolution is the number of bits. The resolution can be defined as the number of different voltage levels used to discretize the input signal. For 8 bits, the resolution values range from 256 states to 429 million states for 32 bits. The Arduino uses 1024 states for 10 bits of precision. The smallest measurable voltage from Arduino, or smallest measurable voltage change in Arduino, is 5 volt divided by 1024, that is 4.8 millivolt. The maximum sample rate is 10,000 times a second. So thank you for watching this video, and stay tuned. We'll discuss more about microcontroller programming, and an interesting hands-on session will be there in coming up videos. Stay tuned for coming videos. Thank you for watching.